Hey guys, okay, so today what we're going to be talking about is different aspects of arcs in a circle. And pretty much we're going to be talking about two things, and then we'll expand on that. So the first thing you need to know is what is an arc. So what I have here, and if you look at this screen, this computer screen, what I can do is they have two things here, and it's talking about a minor arc, which is the orange, and a major arc, which is currently the blue dotted. Okay, and so what I can do is I can drag this, and if you watch how the angle measurements are changing, what you want to look for is when the minor arc changes color and turns into a major arc. Oh, just happened. Okay, so if you watch again here, now the minor arc is the orange one. If I bring him this way, what makes him turn into a major arc, or vice versa? All right, if you can't tell, obviously a minor arc is kind of our smaller arcs, and they're less than 180. Once this minor arc expands to over 180 degrees, then it turns into a major arc. Okay, so the arcs of a circle are kind of exactly what it looks like, the outline part of the circle. All right, and if we look at our notes, a major arc is kind of the bigger arcs. Major arcs are greater, big arc, and they're greater than 180 degrees. Minor arcs are the littler arcs, and they're less than 180 degrees. All right. If you look back at this calculator, and if you were to add up the total number of degrees, and you guys know this from middle school, but the total number of degrees in a circle will always add to 360 degrees. All right, so you know in a quadrilateral the sum of the angles is 360, in a triangle it's 180, and now you've got another thing you're responsible for remembering. A circle always sums to 360 degrees. When our arc is equal to 180, that's a semicircle. So a semicircle is a perfect half circle, and it's an arc whose endpoints on the diameter, whose endpoints are on the diameter of a circle. So if I wanted to draw a semicircle, here's my circle with center, we'll call it C. An arc that's a semicircle, the endpoints need to go here and here, all right, directly on the diameter, and then that is my semicircle. All right, easy? Okay, so for here, what I have here is a minor arc and a major arc drawn on here, and I kind of told you that this guy, AC is 78 degrees. All right, so he is our minor arc. And in math, when we're talking about arcs, this is how you represent it, arc AC. Okay, so we're saying that the measure of arc AC is equal to 78. Now, major arcs, you could also name it AC, but the issue with naming it AC, right, the major arc goes all the way this way because it's the big arc, it's greater than 180. You can't really name it AC because you don't know what way to go. So whenever you name a major arc, you need to name it with 3 letters. And in this case, this arc is ABC. You go in the order that you're connecting them in. And we know that the measure of major arc ABC, okay, is equal to the total number, which is 360 degrees in a circle, minus the 78 degrees that I said AC was. And then for the measure of major arc ABC, we have 282 degrees. I can check that these are right because 78 plus 282 will give me the total 360 that I need. All right, so in example 1, we have here our minor arc is BC, and he is 13 degrees. What's the measure of the major arc in this drawing? Now be careful. BC is my minor arc, okay? So you cannot name the major arc ABC. It has to start at one endpoint, which is, in this case, B. And it's got to loop all the way around. So I'm going from B to A all the way back to C. So that's the name of the major arc. Arc B, A, C. And what's the measure of that arc? Well, to figure it out, you have to do 360, right? Because that's the total number, minus the amount I used, which is 13, and that gives me 347 degrees. Why don't you pause the video, label arc BAC as 225, and then figure out the measure of the minor arc. Okay, so you should have labeled arc BAC, just like connect the dots, and that's 225 degrees, and you should have gotten arc CB is 135. All right, so the next thing we're going to be talking about is central angles. And pretty much all central angles is exactly what it sounds like. They're angles drawn from the center of my circle, all right, and they're created by two radii. So here's one radius, AB, and here's another radius, BC. Okay, this is a central angle because it comes from the center. All right, and the theorem or the relationship between angle ABC and arc AC is that they are the exact same measure. They're equal in measure. So the measure of arc AC is equal to the measure of angle ABC. ABC, yeah, this guy. Okay, so those two are equal. What if I put a point in D here and I wanted you to find the measure of arc ADC? What would you do? What I would do is I would say, okay, well, I've got 360 degrees total, and if I know the measure of arc AC, then I can figure it out. So those are two important little theorems here. But the important thing to know is that if you have an angle drawn from the center of your circle, you can quickly find the arc because they're equal to each other. All right, so on the next page here, I have a couple of examples for you to do. I will work through these first ones with you so I can kind of give you the strategy, and then you're responsible for 9 and 10 on your own. All right, so question 1 says, find the measure of arc PQ. So here's arc PQ, and U is the center. All right, well, I see something immediately here, and I see vertical angles. QS and also PR are both diameters, and they're both straight lines, making these two guys vertical angles. So if this angle, SUR, is 42, then PUQ also has to be 42 degrees, making PQ 42 degrees as well. The next one, ST. Okay, so arc ST is over here, and there's a couple different strategies you can use to try to figure it out. Now, if you think you can figure all these out on your own without listening to me, you can obviously pause it, and then when you figure it all out, you can either play or fast forward it till I have the whole diagram filled in. But if you'd like an explanation, then just keep listening. Okay, so for ST, I have a couple ways I can think about this. I know that PR is the diameter, right? And if I want to find arc ST, what do I know is in this whole arc here, PTR, say. That whole arc has to equal 180. And I've already used up 64 and 42 of that, right? This arc here is 64 degrees, and arc SR is 42. So to get arc ST, I can do 180 minus 64, and the other arc that I used up, which was 42 degrees. So the measure of arc ST has to be 74 degrees. All right, well, the next one it wants me to find is arc TPS. I love these questions because there's so many different ways you can answer them. Let's look at arc TPS. There's a couple of different ways you can think about this. So arc TPS literally wraps around everywhere. It starts at T, and it goes all the way around the circle until it gets to S. The only thing it's not counting is arc TS, right? Because I've looped all the way around. So to find TPS, one strategy you could use is do 360 minus the 74-degree angle. And after I do that, I get 286 degrees. Again, that's not the only way you could get that answer. All right, there's a bunch of different ways. Why don't you try to find the answers to 4 through 10 and pause the video, and then when you've got the answers, check your work. So here are my answers for the rest of these guys. The one that I want you to take note of is RT. You have to be careful with the way that you're connecting him. RT is written as a minor arc, right, because he only has 2 numbers. So RT connects this way, RT. Remember, major arcs are written with 3 letters. Minor arcs are written with 2. All right, so RT goes this way, and he is 116. Why don't you see if you can find the measure of arc PN in this example, and the measure of arc MN in example 10. Pause the video, and I will put the answers up. Okay, so for number 9, you should have gotten the measure of arc PN is 60 degrees, and the measure of arc MN is 90 degrees. The next thing we're going to talk about is parallel chords, and what happens when you have 2 parallel chords in a circle. So if you look down here, I've got a nice little diagram drawn for you, and it's pretty simple. If you have 2 parallel chords, so in this case, in this drawing, we have AD is parallel to BC, then we know the 2 arcs that they form, which in this case is AB and DC, those guys are congruent. So if 2 chords are parallel, the arcs between them are congruent. Okay, so in this case, if the 2 chords in this guy are parallel, we've got AB is congruent to DC. Arc AB is congruent to arc DC. Okay, so in this guy, this is pretty simple. If the first thing I want to do is, I know that these 2 chords are parallel. Okay, that's what's given. So if JM is 38, what's our KL? Pretty simple. It's 48 as well, right? So then we can answer the question, and the question is, what is the measure of arc KLM? Well, actually, you could have figured this out without knowing this, all right? But 142 plus 38 is 180. So what does the measure of arc KLM have to be? 180 as well, because it has to add to 360. All right, for this next guy, I know that opposite sides are congruent in this little square that they drew here, and I know it's a square because it's got 1 right angle and all sides are congruent, which means opposite sides are also parallel, okay? So that means I know this arc is congruent to this arc, okay? And this arc is congruent to this arc, so pretty much I know all of my arcs are congruent. So to find the measure of arc LM, which is the one down here, I know I have 360 degrees total in my circle, and I can divide it by 2. Or not 2, 4, sorry. And so I know arc LM is equal to 90 degrees. Why don't you try to find the measure of arc RPM? So be careful with the way that's labeled here. Arc RPM goes this way. In this example, all right? Here's my one hint. If I know this arc is 132 degrees, then I also know the arc opposite it is 132 because they marked them congruent. And again, you want to find the measure of arc RPM. And you should have gotten 228 for that guy. Okay, on the next page,
Hola, señorita. ¿Cómo te llamas? Me llamo Mike. Me llamo Mike. ¿Dónde está el baño? Feliz cumpleaños. ¿Qué hora es? ¿Qué hora es? La 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 la. Me gusta la biblioteca. Vivo en la Casa Roja. Yo tengo 2 bicicletas. Muchas gracias y de nada. ¿Cuántos años tienes? Un momento, por favor. It's the one semester of Spanish love song. Mi mamá es bonita, mi gato es muy blanco. Perdóneme, perdóneme. La 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 la. 1, 2, 3 y 4, 5, 6, 7, 8, 9, 10. No remember how to say 11. Antonio Banderas, nachos grande y cinnamon twists. It's the one semester of Spanish love song.